Everyone, welcome back. So let's try some problems from chapter 6. We're going to start off easy and we'll work our up to more difficult problems. So in this one we have a specimen of some metal having a rectangular cross section. Okay, it's a rectangle. I like that. And it's got dimensions of 10.3 times 13.4. Totally should have made this more of like a square, but we'll just roll with that for now. Okay. It's pulled in tension with a force of 27,000 newtons. Which produces only elastic deformation. That's good. That helps us out with our equations. Given that the elastic modulus of this metal is 83 gigapascals, calculate the resulting strain. Okay, a lot is going on here. We're going to have to use a couple equations to put them together. So first off, stress is equal to my modulus elasticity times strain. Okay? And that's what we're trying to find. We know modulus elasticity, so if we just knew the stress, that's not a zero, that's supposed to be like a turbofan right there, we'll be able to calculate the strain. Okay, so what's my stress? Well, my stress is equal to the force divided by the area. And what you can see here is I actually have all of these components. I have the force, I have something that can give me area. We can go from there. So let's go ahead and calculate the stress first. So stress is equal to 27,000 newtons, that is the force, over the area, which is 10.3 times 13.4. And that's going to be millimeters squared. If you're wondering why am I not switching to meters squared or doing any conversions right now, that's because I have a very helpful conversion, which I'm going to show you in just an amazing second. But first, let's figure out what this number is. Okay, so plugging this in my calculator, I get 195.6 newtons per millimeter squared. Now, that doesn't look very important to you, but I'm going to tell you something that is magical for all these kind of problems. A newton per millimeter squared is actually equal to a megapascal. So if you got newtons and you got millimeters squared, just keep it, okay? Just keep it, people. It makes it a lot easier on you. Okay, so it means my stress is actually equal to 195.6 megapascals. And this is enough for me to go ahead and start solving the problem, as long as I can see what E is. There we go. So sigma is equal to my modulus elasticity times strain. I'll solve for the strain. I get that my strain is equal to my stress divided by the modulus elasticity. So that would be equal to, let's see here, 195.6 megapascals divided by, that's gigapascals up there, so we make it into thousands of megapascals, 83,000 megapascals. And that comes out to be very, very small. With strain, it should be small. If you get like 1 or 2, you've done something horribly wrong. And so I'll get 2.36 times 10 to the negative third. If you're wondering what's the units, there are no units for strains. It is unitless. Why is it unitless? It's unitless because it's a ratio. Strains by itself is equal to how much you have stretched over the original length. And so that's just, meters over meters or inches over inch. And sometimes in textbooks, they'll give you like units of inch over inch or meter over meter. But that's just, I guess, kind of trying to say, hey, look, there's a unit when there's not actually a unit. There we go. So that's it for this one. Thank you so much for listening, and I'll see you all next time. Bye-bye.